Okay, welcome everyone. This is the working group device management meeting for May 21st, 2025. Remember, this meeting falls under the CNCF Code of Conduct, which basically means be excellent to each other. We don't have anything in particular on the agenda today, I believe. I forgot it the last time. This time I hope to remember. This is a more smaller meeting with fewer people. If anyone who's new here wants to introduce themselves, please raise your hand and we can do a round of introductions, or you can just express what you're interested here. There's time for that, certainly. Other than that, I can talk a little bit about fit array planning, and then we can see whether our standing topic about consumable capacity needs anything. Yeah, that would be it for today, unless someone else has any topics that they want to bring up. Okay, doesn't look like it. So let's jump right in. This is a kind of a recap from last week's bigger meeting with the US Europe friendly time zone slot. We announced that we are trying to slow down a little bit. The main goal for 134 really is core DRA structured parameters to GA, and some more work is needed for that, and we don't want to risk that. So we pushed out quite a few things that we already previously slated for promotion to beta at our KubeCon Europe conference presentation to alpha, basically keeping it in alpha, including important things like partitionable devices. So even that highly looked after feature is probably just staying in alpha. Partly because the beta criteria are now more strict. There is one cap that has been merged, which basically says that promotion to beta, basically it must almost meet all of the traditional GA criteria. And that we don't think that for many of the things that we introduced as alpha in 133, we are actually at that point. Speaking of partitionable devices, for example, the implementation of the scheduling algorithm in 133 was very rudimentary. We are almost rewriting it from scratch right now for 134, and that just doesn't look like it's stable enough for promotion to beta. The one promotion I think that we currently have is admin access, because that's has been in well, as a feature, it already was in 132. We just split it out into receptor cap, and it's a fairly minor thing that may go to beta. And resource claim status is beta already. We were thinking about promoting it to GA, but there's no urgent need, really. If you think about it, with core DRA in GA, the API is there, and beta features can be enabled by default, so it's almost good enough for the purpose of making it readily available. Well, that's roughly the background for this revised planning. Yeah, I can talk a bit more about the blockers for GA if there's interest, but I think that also was discussed on various other locations. But don't want to fragment the discussion too much. But anyway, it's entirely up to you. If you want, I can talk a little bit more. The thing that we have traditionally discussed in this meeting here is the consumable capacity. That is a new feature in 134. I think it's in a fairly good state. We have one cap here. Where do we have it? Let's go to that one. So Not sure what the latest date is, but I think we did quite a thorough review already. Yeah, some more questions from our approvers. That's recent. So it falls under SIG scheduling again. So Dominique is looking at some things, and he's on the call, I see, right? Yeah.
Yes.
So, well, let me just ask: do you think that we are ready to merge that cap? I haven't looked at it recently. Is there anything that we want to discuss online while we are all here?
Yeah. So from my point of view, I don't have any concerns. I was asking Kenzei about his second pair of eyes look, and he was asking questions. So I think there are answers already.
Yeah.
I don't see any blockers here.
Okay. Well, it certainly won't hurt to get the cap merged soon, just to get it out of the way if we are all comfortable with it, because there will be other cap updates later. We have 4 weeks, I think, until cap freeze. So if there are no standing concerns,
Yeah. So
I'm
I can double
fine.
check Kenzei
Yeah.
today, and
Yeah.
I-
I think that would be good. I also
okay.
have my, just a reminder, I also have my other cap PR with updating device stains. I think we are also done with reviewing that. So if you can once more circle back to it, I don't have the URL ready. That
Yeah.
may also be ready for merging.
I think we already approved that.
Yeah, actually I don't remember. I can check after the meeting. Okay, Lionel?
Yes, thanks. Yeah, I had a question about this cap because there was links to external documents, and I was wondering if we should bring the information of this external document in the cap itself, or it's okay to keep them. There was it was pointing, for example, to Google Docs, etc. I don't know if we should work on this.
I think the cap is standalone, a useful standalone as it is, and I'm a bit worried that pulling too much background information will make it too large. So I personally,
Okay.
I'm fine with just providing background references as it's done now.
Okay.
There's always, of course, the risk that those documents go away, so we would need to be careful how they are shared, who owns them. But if it's something that's considered optional, I'm fine with a setup like this.
Okay, makes sense. Thanks.
Not sure where exactly the link is. I probably
Yeah,
find
because
it.
learner, you give me a feedback, so I removed the link from the cap document. Yeah.
Okay,
Okay.
so it's gone.
Okay, you already did it. Okay.
Yeah.
Sorry, I didn't check.
Okay, I think then it's clear. Thanks. Okay. Well, I don't have anything else. We can
But
make it a quick meeting
if
yeah.
we have time, can you briefly talk about blockers?
Yeah. Okay. Well, I can. So for GA, the biggest question is it of sufficient quality? Do we need to add anything with regards to recovery, observability? This whole topic of reliability is what people are looking into. Some of these have been addressed. For example, the DRA plugin support in Kubelet is now, I think, much better than the support for device plugins. We have support for rolling updates with proper handover from one running container to another. I think I already added that in 133. Ed is currently working on detecting unresponsive gRPC servers. So if the DRA plugin goes down for a while, the kubelet at some point needs to consider that if a plugin inactive and not registered, and clean up resource slices to prevent scheduling workloads onto that node where the DRA driver is currently not working properly. So that falls under reliability, and I think it is part of the things that we want in 134, and it seems doable. So it's a bit gray area. We are still extending the feature compared to beta, but I think we can do it and we should do it and not cause that to delay GA. There's enough interest to move forward that I think we should be doing it. The other question is scale. How well does it work at the moment? And that does not necessarily mean that it needs to be a blocker. It might just lead to the situation that we find in scale testing that, well, it works for the original use cases of a handful, and with a handful, I literally mean 4 to 5 GPUs or perhaps 8 for a single pod. And that's good enough. It is what we aimed for initially. We might find that if you do things like 34 or 32 or a maximum number of claims, devices per claims, I think, which is 32, if I remember correctly. And then also multiple claims per pod, that we end up trying to allocate so many devices for a single pod that it just doesn't really work that well with the current allocator code. And that's just then something that we need to document. It's more these advanced use cases that may not work well enough and may lead to a rethinking of how we allocate things. But that is, again, I think, not a blocker. We just need to know where we are and where the pitfalls are and how well it scales across, say, multiple nodes. That's the biggest thing, and that's what's currently being planned to test. Ale from NVIDIA is working on that. He had discussions with SIG Scalability, and he will set up testing how it's traditionally done with SIG Scalability. There will be a big cluster brought up, I think 500 nodes initially, if I remember correctly. And once the job is stable, it might even become more. And it will become part of regular scale testing that SIG Scalability does. So the testing will really bring up a big cluster. It will deploy probably the example driver in a configuration that we want to test, and then try to get pods running. So pretty much like it's done with normal pod scheduling, except that we also have a DRA driver and claims involved. And then we can think about how many other different scenarios we want to test. How many claims per pod, how many drivers per node, how many devices per node. All of that are different dimensions that we want to explore eventually. But just the initial answer that it doesn't completely fall over with typical use cases for the core DRA with large numbers of nodes, I think that would be sufficient for GA. Not actually sure what conf tests means. Configuration tests, probably what I just described, that we want to explore different configurations for at scale and see where we land with performance. There's one more thing that I want to add, and that is a timeout mechanism in the scheduler. I discussed that already with SIG scheduling on Slack. If the filter operation takes too long, and that literally is time bound, probably needs to be configurable because it's up to the admin how long they think they can afford to spend in the filter phase in their cluster. But once it's configurable, we can have something that's relatively large by default, and then just give people the knob to tune if they want to. The purpose is to prevent those abnormal scenarios where the allocator just goes into trying out lots of different combinations of devices and they all fail and it never really finds a good solution. So that is something that I also intend to add for 134. Yeah, Dominic?
Yeah, I saw this discussion. I was on vacation, I think, at that time. But isn't a problem that part of the scheduling of the array, there are several API calls involved in it?
Not really, no.
Mhm.
The current design is such that it's all almost completely local. The classic DArray had this problem of making API calls, but even that got solved. No, so right now it's all local computation. It slurps in the state of a cluster from an Informer cache. So no additional API calls, really just cache-based, looking at the state of a cluster, computing potential solutions, and then in the filter phase, it identifies a potential allocation result per node. The scheduler then picks a node. In reserve, we plan, I think, anyway, it's the actual resource claim status update is happening in that Go routine that does the device, the pod binding. So that's the first time that we actually then do an API call, and that is not in the main scheduling loop.
Okay, one thing that we are currently working on is making the setting unschedulable status as asynchronous call. So that would be one thing that may help here. Although I'm not how intensive that case was, because I think you mentioned the scenario when there is only a few pods are unschedulable because they cannot fit. So that shouldn't be a big issue either. But anyway, we are trying to make
the one thing that is relevant for DRA is that, and I remember that discussion that you mentioned, when a pod uses a resource claim template, it is a fairly normal situation that you create the resource, the pod gets created, the resource claim controller still needs to create the resource claim for it, and that will happen fairly soon, but it will not be immediate. So it's fairly likely that the scheduler will do a scheduling attempt and can't proceed with it because the resource claim isn't there yet. So avoiding that is one situation where the pod status gets updated once and then immediately or relatively soon there will be a second pod scheduling attempt for the same pod now that the claim exists, and it will then continue, but it will lead to some additional load on the API server for something that is fairly normal. So I think we were discussing whether it could be possible to delay that pod status update just a little bit.
Yeah.
So that the next scheduling attempt is already in progress, and we never really store that one status that basically says waiting for resource claim to be created. I think that's an optimization. I don't see it as a blocker for GA.
Yeah, I think we have this case in mind, and we try to add sufficient delay.
Yeah.
Okay.
Another thing GA related is version skew testing. That's really a general thing for all features, but we don't have good infrastructure for doing it. The current mechanism is that you do it manually. You basically figure out how to bring up a kubeadm cluster, and when you change core components, it's all pretty ugly, because then you need to document what you have tested somehow, and people are not necessarily prepared to reproduce it. I want to get a little bit further and automate version skew testing in Kubernetes. And my current plan is to use the local up cluster script, which already has all the necessary end variables, for example, to bring up a cluster with an etcd database from a previous invocation. So you can simulate upgrading the API server. It's a matter of also compiling the older Kubernetes that you want to skew against, and then figure out a few things like, well, how do I do that in a broad job? How do I control it from an E2E test? And then run some E2E tests against the old cluster, update, run some other tests again for the new one, and how to organize that. So that's also part of it. Otherwise, if I don't get that automated, we will have to satisfy this KEP requirement by doing it manually again. Okay. I hope I answered the question. If not, just shout and I can try to elaborate a bit more. Nope. Okay. If that's all, then thanks again for your time, and we'll see each other.
Craig, would you mind me asking whether, like, I think the last comment that you just comment in the KEP consumables capacity is about the changing from the Boolean into the enum.
Yeah, right.
Should I update it here, or is need some more discussion, or I don't know.
I'm not sure. It's actually not associated. It's probably it's not even in the attached to any source code lines. Or let me go to the conversations. I'm not seeing it. Should be somewhere.
Yeah, it's
I misspelled it. There it is. Yeah, this shareable versus shareable is just awful. Why couldn't the British and the US agree on one spelling? I would make the life so much easier for the rest of us and for themselves, but it is what it is. So yeah, the question is, API design guidelines say that we shouldn't use Booleans, because there's always the risk that a future alternative might be needed beyond true false. There's some truth to it. I'm not sure how applicable it is here. We might need a second opinion from an API reviewer.
I mean, is this able to be updated after the KEP is merged? I mean, I don't know when the API review.
Yes, I think that's indeed perhaps the best approach. We proceed with the KEP as planned, and then re-raise it as a question during the implementation review. I think that's my preference.
Thank you. So the schedule will be like, if this PR is merged, then I can create another PR for the API only PR to the Kubernetes or something.
Your PR against Kubernetes needs to be complete. So API plus implementation, because we wouldn't merge just the API.
Oh, okay. Because I see some guidelines say that we should separate the PR for the API first to get the reviews before implementing, something like that. Is that right?
The best practice is to separate it into different commits.
Oh,
First
okay,
commit, first commit are the manual API changes. So types.go, strategy, dropping fields, all of that goes into one commit. Second commit is automatically generated API files.
Okay.
At that point, with a second commit, it should compile. It should be complete enough to bring up a cluster, to generate the open API docs. So that is self-contained. It could be merged like that, but we don't, because then the implementation is missing. So what you then add is perhaps a third commit with the implementation of the API, basically the scheduler plugin change.
Okay, thank you.
And then it can be reviewed by an API reviewer who will just look at the first commit essentially, and SIG scheduling can look at the third commit, and once everyone is happy, we merge it. The purpose is to avoid partial implementations. If we merge the API and then don't follow up with the implementation, we have to revert the API again, which is always ugly. So we don't do that.
Yeah, thank you. Another silly question is that if like it's got the reviews and needs some change, should I just add another commit, or should I just have to rebase and like amend the commit, like for example the API?
It depends a bit on your reviewers. I think it makes more sense to amend the commits because then we keep this property that someone can look at the first commit and see all the API changes. If we start out with the 3 commits that I described, and then you add more with fix-ups, then someone has to look at the whole file diff to get the full picture.
Okay.
And that's worse because then they see everything, including the automatically generated file. So yes, please amend commits, do a force push. Be careful that you don't change the base. So keep the base commit the same, because then reviewers can look at this force push link that GitHub creates. And they will be able to do an incremental review to some extent. If they care about what you changed since the last review.
Okay, thank you.
Yeah. And coming back to this claim mode versus shareable true, it is probably worth adding a meta comment to capture this discussion, even already in the CAP document, because it is an obvious thing that people may ask about. So if you below shareable bool, you add a comment, standalone, not attached to any field, just explaining why bool was used instead of, say, claim mode, or which alternatives were considered, then an API reviewer who looks at just the types.go file will have some background that is relevant for that choice, and they may then make up their mind whether it was the right thing to do or not, without having to restart this discussion from scratch.
Okay, I will add alternatives into the CAP document. Yeah. Thank you.
I think we discussed this before, but it's almost impossible to find that discussion again in GitHub, because there are too many discussion threads and some of them get automatically resolved and so on. So it's, yeah, things tend to come up more than once when different people look at things again.
Okay.
The argument.
Options?
Sorry?
Can you think about other options already for the shareable?
We can, yes. One thing I wanted to say is this is not the first bool that we have in our API. There are a few others, and we just decided to do it that way, despite that guidance, because we really couldn't think of good enum values and didn't see a need to extend that in the future. So it's a guideline. It doesn't mean that it absolutely has to be an enum.
Mm-hmm. So yeah. So I think this Boolean means that some of the capacities are consumable, right? Well,
No, it's separate.
all.
No, neither. It's basically really just a statement about the device. So it basically says that the device can be allocated more than once.
Okay.
And that enables some of the capacities to be consumable, but it's not required. So
Okay.
once
So if
once that is true, then we can look at, or then we have the ability to also have consumable capacities. If it's false, we can't.
Mm-hmm. Yeah, and capacities can be consumable in many different ways within the same resource slice, I think, depending on the consumable configuration.
Yeah. So basically, this is really just, well, it's a starting point for the whole feature, but it's not making directly a statement about the individual capacities in that device. I think that's the key point to remember.
Okay.
Okay. I think that probably then was all. And yep, looks like we're good to go. Thanks everyone. Goodbye.
Yeah. Bye bye.
You.
Thanks.
Thanks. Bye.
You.